All right, so we are just going to introduce to you what a sequence is today in this first section and look at the two different types of formulas that you can see for a sequence. So one is known as the explicit formula and the other a recursive formula. All right. So mathematically speaking, a sequence is defined to be a function. So that means that for every input, there's a unique output. Okay. And the domain of this function is typically going to be the set of positive integers, or we can define that to be the whole numbers. So it could be 0, 1, 2, 3, 4, and so forth as domain values. Sometimes 0 is excluded and you simply start at 1. Okay. When you take the numbers of a sequence, they can be translated into ordered pairs, and you can plot those in coordinates in the coordinate plane. You would not connect those points with a curve, though. Okay, this is not continuous. The graphs of these would, I guess you could call them, they'd look like scatter plots in a sense. There would be a pattern to the points, though. All right. So we can represent these with function notation. We can say f of n. Typically, we use n rather than x for our domain, our input. Or more often, you're going to see it represented as a sub n. Okay? And in this first example, we have an explicit formula. I'm saying f of n or a sub n equals the explicit formula 1 over n. Okay? And that results in numbers 1, 1/2, 1/3, 1/4, etc. Okay, you get each of those numbers by plugging a value in for n. So if I want a sub 1, that's the same as f of 1 by the formula. I would be plugging a 1 in for n. 1 over 1 is, of course, 1. If I wanted to find a sub 2, that would be the second term of the sequence. That's the same as f of 2, which would be 1 over the n value of 2. Okay. Now again, this is known as an explicit formula. An explicit formula, you can use it to find any term of the sequence directly. So like if I wanted the 100th term, a sub 100, or f of 100, that would simply be 1 over 100. I can explicitly get that value without knowing any other terms in the sequence. Okay. All right, example below, write down the first 3 terms of this explicitly defined sequence. A sub n equals n minus 1 over n. Don't worry about the braces in that formula. Sometimes you use braces, other times you don't. Okay. So if I want the first term, that would be when n is 1, okay? And it would be represented with the notation a sub 1. So that's going to be 1 minus 1 over 1, or 0 over 1, which is, of course, 0. If I want the second term, that's when n is 2. That would be represented by the notation a sub 2. So plug a 2 in for n, that's 2 minus 1 over 2, results in a 1/2. And for the third term, n would be 3. It's represented with the notation a sub 3. This would be 3 minus 1 over 3, or 2/3. Okay, and it's customary once we find these values, this is a set of numbers, right? So you typically represent sets with braces. So I'll put 0, comma, 1/2, comma, 2/3. The pattern's going to repeat itself all the way up to the nth term of the sequence, which is just represented by n minus 1 over n. Any questions on that example? All right, now in example 2, we have several sequences listed with some of their terms already given. And what we need to do is look for some patterns so that we can come up with the explicit formula that represents that sequence. Okay? So let's start with the top left sequence there. 1 to 4, 4 to 7, 7 to 10. What are you noticing? Yeah, you're adding 3 each time, right? Okay, so repeated addition by 3 is the same as what other operation? Multiplication, right? So let's start with our formula a sub n, beginning with 3n then. Multiplying by 3 is the same as repeated addition by 3, right? Now, if I leave it alone, that's not going to work. Okay? Test some values here. So if I try to find that first term when n is 1, 3 times 1 would be 3, but I need the first term to be a 1. So how do I fix that? Simply subtract 2. All right, and then test that with other values in the sequence to make sure it matches those as well. So if I were to plug 2n for n, 3 times 2 is 6. 6 minus 2 gives me the second term of 4. Okay? I would always recommend testing a couple different values of the sequence because sometimes we'll find a formula that works for one of the terms but doesn't for the other. So test it for multiple. Okay? All right, next one we have e to the second over 2, e to the third over 3, e to the fourth over 4. I think this is an easy one. A sub n equals, what do you think? About e to the power of n over n itself, right? Okay, now here you don't technically need to know the value of e, but recall we looked at e back in our exponential logarithmic unit. Anybody remember what it approximates to? .718. Very good. Remember, this shows up in a lot of application problems, one of which was continuously compounded interest. We had the PERT formula, P times e to the power of RT, right? Okay, next one, bottom left. -1, +4, -9, +16. Okay, if the pattern continued, the next would be -25, +36, -49, right? Okay, so if you take all of the negatives away and just focused on the positive number of each of those terms, they're all perfect squares, right? So we could begin our explicit formula with a sub n equals n squared. Then I have to now account for the fact that every other term, beginning with the first term, is negative. Okay? Now this might be a question for my honors algebra 2 students. Anybody remember how to handle that when every other term is negative? No? All right, so all we have to do is multiply the n squared by -1 to the power of n itself. Okay, let's test that out for the first couple values so you can see how it works. If I want the first term a sub 1, that means n is 1. 1 squared is, of course, 1, and then -1 to the first stays -1 to where my result itself is -1, right? Okay, but now what about the second term, a sub 2? That would be 2 squared times -1 to the second power. And we know 2 squared is, of course, 4. And now we have negative 1 being raised to an even power, which is going to result in positive 1, right? So it eliminates the negative result. Okay. All right, now it's customary. I wrote it as n squared times negative 1 to the power of n, but understand a lot of times you'll see it with the negative 1 to the power of n written first. Okay. All right, last one here. 1, negative 1/2, 1/3, negative 1/4, 1/5. What would the next one be? Negative 1/6, right? Positive 1/7, so on. All right, once again, if you take the negatives away, just focus on the positive values of each of these, you could simply get away with the explicit formula 1 over n. Now you bring the negatives into play, and we want to notice that it's now the even numbered terms that are negative, right? So if I multiply this by negative 1 to the power of n, that's not going to cut it. What slight adjustment needs made? I wouldn't want to do negative n because that's not going to change the sign on negative 1. That's just going to make it become 1 over negative 1. Okay. Any other thoughts? Very good. You can make the power n minus 1, or you could also do n plus 1. Either one should give you what you need. All right, so let's, again, test a couple out. So if I want the first term, a sub 1, that's an n value of 1, so 1 over 1 times negative 1 to the power of 1 minus 1. So that's 1 times negative 1 to the 0 power. What's the negative 1 to the 0 power? 1. 1 times 1 is, of course, 1. All right, a sub 2, n is 2, that's 1 over 2 times negative 1 to the power of 2 minus 1, or 1/2 times negative 1 to the first power, resulting in negative 1/2. So notice by using either n minus 1 or, again, n plus 1, the even numbered values of n are actually making the power on negative 1 odd, which is going to keep it negative. Okay? All right. So on your Delta Math assignment tonight, there's going to be a few that are like those last two examples there, where every other term switches signs. Delta Math is intuitive. It'll recognize, like if you put n plus 1 or you put n minus 1, it should recognize that both of those are equivalent. Okay? So it's not like it's going to mark it wrong if you do one versus the other. Okay? And it also shouldn't matter, like as far as order. If I did that typed in versus that, it recognizes those are equivalent. Okay. All right, give me a second here.